Hi students, in this video we're going to look at applying angle theorems. This is part one of two videos. We'll look at two angle theorems in this video and two more angles in another. So our learning goals for this video, so after watching this video you should be able to apply the first two angle theorems and calculate unknown values, whether they be lengths or angles. Right, some things you'll have to recall. First of all, the parts of circles and their terminology. So we're talking arcs, sectors, segments, radii, chords, those words and those ideas. We should remember what those are. We should remember how to carry out our geometric proofs, making statements, writing reasons, and also remember those reasons either written or using the symbols. Alright, so our first angle theorem states that the angle subtended by an arc at the center of a circle is twice the size of the angle subtended by the same arc at the circumference. Now what does that mean visually? Let's say we've got our angle here that's subtended at the center. So we'll take that as O, and we've got our arc here, AB. Let's say then using A and B, we now draw an angle at the circumference up there, and then down to B, imagining that line straight and going towards B. Okay, what we're saying is that this angle at the center is double the size as the angle at C. So let's say the angle at C is A degrees. In the center, this angle here will be 2A degrees. It'll be twice the size. All right, let's look at that in an example. So let's say this angle here at the center is 72 degrees. So what must the angle at A be? Well, using this theorem, we know that 2 times A must be 72 degrees using the angle at center theorem. Sometimes you call it the arrow rule or the chevron rule, because it's got that arrow or chevron shape, or the angle at center theorem is a fine way to refer to it too. So that angle here at 72 is double the angle at A, so rearranging that, A must be 36 degrees. And that's all there is to finding an angle in this particular situation. Alright, angle theorem 2. The angle in a semicircle is 90 degrees, so what we've got here is a diameter. Okay, in our circle, so it goes through the center, and that's what makes this part of our circle a semicircle, going through the diameter and a core and the arc going all the way around from one end of the diameter to the other. Now this proof is actually pretty straightforward. We know the angles of a line here on this line is 180 degrees, and using the theorem we just proved, this angle at the center must be double the angle made at the circumference. So this angle up here must be half of 180, 90 degrees. And that's where this second angle theorem comes from. All right, using that in an example, let's say we've got a bunch of angles here and we have to work out A. We know that the angle ABC equals 90 degrees, and we know that because, like we just showed, the angle in a semicircle is 90 degrees. Now to work out A is just going to be 180 degrees, subtract 90, subtract 35 we were given, because we know the angles of a triangle add up to 180, so the value for A must be 55 degrees. And that's how we would apply the second angle theorem to calculate unknown values. Alright, now finally let's do one last example where we have to calculate the value of A. So A is going to be this angle up here, angle ACB. Alright, so what we can do is we know that AO and BO, they're the same length because they're both radii of a circle. If O is the center, AO, BO, both radii, both the same size. So what that means is we've got a right angle triangle. So we can say angle OBA equals 40 degrees. Because we've got that isosceles triangle and the angles opposite equal sides, they have to be the same. Now if that angle is 40, then angle AOB is going to be 180 degrees minus those two 40 degree angles, 40 degrees there at B, 40 degrees at A. So our angle at OAB is 100 degrees. Then we also know that 2 times A, 2 times our angle at the top here, is going to be equal to 100 degrees, this angle here at the center. Because we know from our chevron rule, or our arrow rule, the angle at the center is double the angle made at the circumference. So rearranging that, A must be 50 degrees. And students, that's another way of how we can use these theorems, along with some others that we know, like angles of a triangle. Like this one here, angles of a triangle, we should have put in for that step, that second step there, and using that to find unknown angles. Alright, so students, after watching this video, you should be able to apply those first two angle theorems to calculate unknown values.